In this video, we're solving the simplest variety of constant acceleration kinematics question. So we're told that we have a car that starts from rest, meaning the initial velocity is 0. Then it begins to accelerate at 3.8 meters per second squared in a straight line, and it does this for 5.7 seconds. And the two questions were asked, what's the final velocity and what's the displacement? So to get the final velocity, we're going to look at our velocity as a function of time. It's one of our core kinematics equations, v equals v naught plus at. And we were told the car starts from rest, which means v naught equals 0, so that term is gone. So our final velocity v is just equal to acceleration times time. So now we can plug in the numbers. The acceleration is 3.8 meters per second squared. The time, 5.7 seconds. And I kept the units on all the terms this time just so we can verify that our units are going to come out correctly to meters per second. So the seconds cancel and we get the right units there. And so our answer comes out to about 21.7 meters per second. Now I do want to point out that just as a rule of thumb, we ordinarily round everything off to 3 significant digits. But if we're concerned with keeping track of the correct number of significant digits in this problem, everything was given to us as 2 significant digits. So this is a little better answer. I can round the answer to 2 significant digits. And we call it 22 meters per second. So in the second part of the problem, we want to find the displacement of this car, and that means the change in position. So we're going to look at our kinematics equation for the position as a function of time. So there's our usual x equals x naught plus v naught t plus 1/2 at squared. And ordinarily, I'll just go ahead and put an origin at the starting point of the car. So we can just indicate that our starting point is going to be called 0. And then we'll solve for the final position of the car, and that is the displacement. So let me make this point real quick. I can always rearrange this equation as x minus x naught is v naught t plus 1/2 at squared. And on the left-hand side there, that's the final position minus the initial. That is the displacement. But by setting our origin at the initial position, the final x value is just the same thing as the displacement. Now remember, our initial velocity was 0, so that term is gone. And this cleans up to just 1/2 at squared. So we plug in our acceleration of 3.8 meters per second squared, and we had 5.7 seconds go by, and we need to square that term. Now paying attention to the units here, when I square that time, I get seconds squared, which then cancels that denominator for the acceleration term, and we end up with units of meters. So the answer turns out to be about 61.7 meters. And again, if we're paying close attention to significant digits in this problem, we should round that off to about 62 meters. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.